Webflow had its biggest outage yet, and we finally have details about what happened. And I wanted to quickly go through what happened and how they handled the communication, because there's definitely something weird happening. But also just wanted to explain the technical parts in case you were interested, but you don't understand what exactly they explained in their blog. I'm also testing a new setup, so bear with me. So this happened in 4 main phases. The first 2 were mainly just DDoS attacks, as it seems. If you don't know what that is, you basically have your server here, and then you have traffic coming in from all sides in humanly possible rates. And you know how much you're getting, so you're fine. But then someone hires a bunch of bots, and they begin to just spam your server in hopes that it will just overload and it will not take any more requests. So they did what you would do in a DDoS attack, which was start adding a firewall. So you can imagine there's some kind of layer of protection that checks the request before and stops them by somehow identifying if they're bots or not. But they also blocked IPs, so they could block the specific attackers that were sending their requests. They also said they improved the database efficiency, which I'm not sure what that is yet, but we can assume it's just some kind of index, which we will talk about later. Phase 2 was basically the same thing, but it was the next day in the morning, and that one took them about 2 hours to mitigate, or according to them at least. If you were working on those days, you know that it definitely felt like it was a lot more. So this is where it starts to get a little muddy. Now, phase 3 was the second half of the second day. And this actually didn't happen because of the attackers directly, but this happened because of a small mistake. Let's see what they had so far. They had a single socket CPU running their main database backend, and they decided to upgrade to a dual socket CPU, which, fair enough, that sounds like a good idea. 2 is better than 1. The only problem is that this is a completely different architecture. It is 2 CPUs, but each of them has its own memory. And in order to communicate between each other, everything needs to go through this bridge, which introduces a lot of lag. And specifically, according to them, their write operations were 300 times slower, and replication was 500 times slower, which is pretty crazy if you think about it. Like, imagine adding a div to your Webflow site and it usually takes 1 second. Now it takes 300 seconds. It takes 5 minutes just to save the one change you made. So obviously this is pretty bad. And this upgrade took 2.5 hours just to upgrade from one to the other. And then the problems just kept going for over 5 hours. So in order to deal with it, they turned off a bunch of data pipelines. They turned off new signups, they turned off a bunch of features, and they put all of their engineering team on this. Then after all those hours, their database vendor told them, hey, you should probably go back to a single core. And this upgrade or downgrade, this took 2 hours. And after that time, it was finally getting a bit more stable. And all of this happened in just 2 days. Now let's go to phase 4, which is the last day where this happened. And this time, the main target was the marketplace. So they were getting another DDoS attack. The malicious attackers were targeting the marketplace this time. So they noticed it in the morning and they immediately took the marketplace offline in order to deal with it. And they also disabled user signups again. And then they also optimized read operations, which is most likely just adding more indexes to their database. So if you don't know what that is, whenever you have a table in your database, so let's say this table holds all of your collections, right? And it usually has an ID here. So everything usually has an ID. Whenever you make a table with an ID, that ID is also usually the primary key and an index. An index is basically another table, a much smaller one, which only has 2 columns. One of them is ID, and the other is a pointer that points to a point in memory where this row is saved. So these IDs are usually sorted in some way that is easier to filter through. So whenever you're looking for something, you can look through this small table, and whenever you find the thing you're looking for, you know exactly what part of memory you need to look for in order to find that specific row. So that's probably what the optimizing read operation was. They said their database vendor also identified a known session count bug, which means that their database server would think that more or less people are connected than there is in reality. So you can imagine like the server might think it has a lot more users, so maybe it takes the wrong actions that it needs to do. And their vendor also recommended 2 things. The first was reducing slow query logging, which is just a service that identifies slow queries and it logs them into a file or whatever system they might have so that they can see when or where those slow queries happened and they can figure out what was causing them. But this system just puts extra load on the server, so they had to reduce the amount that they were doing. And then they also had to disable aggressive memory decommit. So the simple way to explain this is that the database will ask the system or the CPU for some memory. This is the memory. And it says, hey, I need this much memory. Can I have it? Then the system responds, yeah, here's your memory. And it starts using that memory in order to do some kind of operations and save and whatever. And then when it's done, it says, hey, you can have it back. So now it frees it up. It doesn't use it anymore. And then when some new request comes in, it's like, hey, I need that memory again. So it takes it back. This takes some back and forth, and it takes some resources in order to allocate that memory. And basically making this less aggressive means that the database will ask for this memory. And then when it's done, it's like, hey, I'll wait. Maybe another request comes in and I can just reuse this. So another request comes in and it reuses that memory that it was already using. And then if it sees that it really doesn't need it, then it will just stop using it and free that memory. After everything started to stabilize, they wanted to make sure this doesn't happen again, at least in the next few days. So they took their single socket CPU and they upgraded, this time not to a dual socket CPU, but to a higher capacity single socket CPU. So that's everything that happened there. It seems pretty stable right now. I've been working on projects on Friday and it seemed pretty fast. It seemed pretty good. So I guess crisis averted, at least for now. But this definitely made people a bit skeptical about putting too much trust into Webflow. Although this doesn't happen very often, to be fair. This has been definitely an outlier, but I've seen a lot of people blame the amount of unnecessary features or the enterprise focus and all of that. And I think there is definitely some kind of merit into those comments. It definitely feels like some core functionality of Webflow wasn't being taken care of, and instead there was a lot of push for new features, especially for the enterprise side. But I would love to know what you think, and if you found this video helpful or informative, let me know. And yeah, have a good day.